When we calculate the present value of a bond, we used the yield to maturity as the discount rate. At that point, we only loosely defined what a yield to maturity is. We simply said it is a discount rate that's appropriate for the level of risk of the bond's promised cash flows. But at this point, I'd like to dig a little bit deeper into what yield to maturity is. And so in order to do that, we're going to first define yield to maturity. We'll use words first, and then we'll use equations. And then we'll actually take it to a problem and compute it. And then we'll talk about the special relationship between the yield to maturity, a bond's price, and its coupon rate. So what is the yield to maturity? Well, you could say that it's the discount rate that makes the present value of a bond's promised cash flows equal to its price. And that's a purely mathematical definition, and it's true, and it's exactly what it is. But it's not altogether intuitive. So let's talk about what's really going on here. So suppose that you identify a bond and you know its price, so what it's selling for in the market, you know its time to maturity, you know its coupon rate and promised coupon payments. Then the yield to maturity is something that is sort of conceptually like an expected rate of return. And here's what I mean by that. So let's suppose that you purchase the bond at its current market price. And then you hold the bond until it matures. And so in doing so, let's suppose further that you receive each and every one of those cash flows that the bond promises exactly as it specifies in the contract, and you appropriately reinvest each one of these periodic coupon payments. Okay, so if all of that happens, then the yield to maturity is your rate of return. Let's go now to the math. And so I've set this up where we have a few definitions. So I'm going to define these terms C and P and T and R. So C is just going to be the coupon, P is the par value of a bond, T is the number of periods until maturity, and R is some discount rate. And so if we know all of these things are true for some particular bond, we can go straight to a timeline as we did before, and it's going to look like this with T periods. We're going to see a series of coupon payments, and then we're going to see a par value repayment also at time T. Now, when we move to valuation, and if we use a formula that combines the present value of an annuity with the present value of a single future cash flow, we would say the price is equal to the present value of the coupon stream using T, or the number of periods until maturity, as the T in the annuity factor, plus the present value of the par value repayment, again using T as the exponent in the denominator because that par value repayment occurs at time T. So again, we've got the present value of an annuity plus the present value of a lump sum. When we first started this analysis, recall that we had a par value, we had a T, we knew how long the bond was, we had a coupon rate, and we had a yield to maturity, and we just said R is equal to YTM divided by 2. And we inserted that in all of these places for the R. Okay? And so in other words, we had 4 unknowns and we solved for the 5th. And what we were solving for is price. But that setup may not always be true. And in fact, in most cases, when we actually have market data, it will not be true. So if we actually have market data, we, of course, still have par values. We know the time to maturity, and we know a coupon rate, right? Because we can observe the bond contract. But if we're looking at market data, what we actually see typically is the bond price, okay? And so it's actually the R in the formula that we don't have, okay? But as before, we have, there are 5 variables here, and we only know 4 of them. It's just a different set of 4, right? And so mathematically, one could solve this equation for R as well. And in fact, if we solve for R, we would say that yield to maturity equals R times 2. And this stems from the very definition of yield to maturity. So remember the words that we use to define yield to maturity. We said yield to maturity is the discount rate that sets the present value of the bond's promised cash flows equal to its market price. Now look carefully at this formula and see what's happening. Start with the right side. Okay? This right side of the formula is literally a present value formula, right? We've got the present value of an annuity and the present value of a single distant cash flow. We're adding them together, so this is literally the present value of a bond's promised cash flows. Okay, and so what are we doing? We're finding some value of R, which is ultimately related to the bond's yield to maturity, that establishes some equality. And what are we setting all of this present value equal to? We're setting it equal to the bond's price.